Welcome to the TrackPad's Military History Podcast, where we bring the terrain, the tactics, and the stories of soldiers to life. Each episode goes deeper than the written article, giving you a front-row seat to the battles that shaped history. Discover more at trackpads.com.
At dawn, a battlefield seems to hold its breath. The air is cool, the ground still damp with night's moisture, and across the river or ridge there is silence, except in the places where combat engineers are already at work. Engines rumble low as bulldozers idle in the mist. Sappers coil detonation cord and lay out shaped charges by feel, their hands quick from habit. Bridging sections check their calculations one last time, whispering over load limits that will soon be tested by tanks and trucks. Before a shot is fired, before artillery cracks the air, engineers are already sculpting the terrain. They are the advance guard of possibility, the unseen force that makes the difference between stasis and momentum. Where others wait for orders to move, engineers create the conditions for movement itself. Combat engineers are paradoxical soldiers. They fight wars by destroying obstacles, by building passages, and by reshaping landscapes that would otherwise deny progress. They are armed not just with rifles, but with saws, shovels, explosives, and steel beams tools that transform the commander's intent into physical reality. Their battles are waged against rivers, cliffs, minefields, and concrete walls, all while under the shadow of enemy fire. Yet their work rarely makes headlines. A bridge that holds under armor is invisible to history. A minefield cleared in time is quickly forgotten. But to those who march across their roads and through their breaches, engineers are not hidden at all. They are the reason those soldiers are alive to keep fighting. The battlefield itself is their canvas, and time is their most precious material. In war, hours can mean the difference between seizing momentum or ceding it forever. Engineers are the ones who create hours where none exist, working through night and storm, improvising when materials fail, and risking exposure so that momentum never dies. A culvert replaced before dawn can feed an army's supply lines. A demolished bridge at the right moment can halt an enemy's advance cold. These decisions are small in scale but vast in consequence. Engineers turn mud into road, river into passage, rubble into stronghold. In so doing, they determine not just how armies move, but whether they can move at all. They are, in truth, the arsenal behind the lines. Their work rarely looks like glory. More often it looks like sweat, grime, and improvisation in the most hostile places on earth. Yet every great maneuver in history, from armored blitzes to urban sieges, rests on their shoulders. They are builders and breakers, sustainers and saboteurs, whose skill turns blueprints into survival. To understand war without them is to misunderstand war itself. Terrain as a weapon is an idea that combat engineers understand more intimately than anyone else on the battlefield. To most soldiers, ground is either cover or exposure, an obstacle or a path. But to an engineer, it is something malleable, something that can be shaped into a shield, a trap, or a passage. A low ridge is not just a line on a map, but an opportunity for revetments, dugouts, and camouflaged fighting positions. In a few hours of labor, dirt becomes armor, trenches become networks of survival, and an open slope becomes a killing ground. For the infantrymen who later occupies those positions, the difference is measured in lives saved when the first barrage lands. Terrain is not neutral. It is either prepared or unprepared, and engineers make sure it favors their own side. Cutting roads and switchbacks into the most unforgiving ground is one of their oldest and most vital tasks. An armored battalion might see a mountain as a wall, but to engineers it is a challenge waiting to be carved open. Bulldozers, graders, and chainsaws tear into slopes, clearing pathways where only rock and root once stood. Corduroy roads logs laid side by side turn swamp into firm footing for trucks. Metal track or matting spreads across bogs to prevent vehicles from sinking axle deep. These improvisations don't just speed movement, they make it possible. In war, the shortest route on the map is useless if the terrain swallows machines and men. Engineers ensure that the map becomes real by creating the road to victory, sometimes at the cost of sleepless nights under fire, sometimes in the face of exhaustion so severe that every shovel strike feels like lifting the world. Equally critical is the darker art of denial and delay. Combat engineers do not just build, they destroy with precision. They plant demolition charges on bridges and culverts, timing the blast so that friendly forces can pass but the enemy is halted cold. They collapse tunnels, crater rail lines, and emplace obstacles that funnel enemy movement into predictable killing zones. Done correctly, these actions can fracture an opponent's rhythm, forcing them to divert entire divisions or abandon timetables. The decision of when to blow a span or collapse a road is a commander's gamble, but the engineer's skill makes it work. When successful, denial is invisible, an enemy forced to halt, reroute, or expose themselves without realizing they've been manipulated by carefully planned destruction. The ground itself becomes a delaying weapon, wielded by those who know its weak points best. Deception is another subtle but powerful role engineers play. At night, they may lay down a false road with just enough signs of traffic to lure an enemy reconnaissance drone. Dummy bridges, fake emplacements, and heat decoys draw fire away from the real axis of advance. Just as important, engineers erase their own work to conceal intent. Tracks are brushed away, freshly dug soil is covered with foliage, and bridging equipment is hidden under camouflage nets. To the enemy, terrain must look unchanged until the moment it betrays them. The psychological toll is heavy. An opponent who cannot trust what they see moves more cautiously, probes more slowly, and hesitates to commit. Engineers exploit that hesitation, bending not only the land, but the enemy's perception of it. One vivid example captures the full scope of this power. On a contested ridge, a brigade awaited attack. By day, engineers carved revetments into the slope and dug concealed approaches for counterattacks. By night, they hacked a bypass road through a gully so armor could move unseen. They emplaced demolition charges on a bridge that could be sacrificed at the last moment, while scattering decoy tracks and lights to mislead enemy drones. Within a week, the ridge was no longer a feature of ground. It was a fortress and a trap, a weapon in its own right. When the attack came, defenders held, armor reinforced, and the enemy's momentum broke. The engineers had not just prepared terrain. They had remade it into a battlefield designed to kill. Minefields and wire are often thought of as static defenses, but for soldiers in the field they are living, breathing threats, psychological weapons as much as physical ones. A belt of mines does not just block ground. It infects minds with hesitation, slows movement, and erodes confidence. Breaching these obstacles is a deadly art form that combat engineers have honed into choreography. The steps are known as SOSRA. Suppress the enemy to keep their heads down, obscure the sight with smoke or electronic jamming, secure the flanks, reduce the obstacle, and then assault through the cleared lane. On paper it sounds like order. In reality, it is chaos. Under tracers and artillery, engineers move with rehearsed precision, every action timed to the second. The breach lane is not just a path through wire and mines. It is the artery of battle itself, and the pulse must not falter. Tools shape how that artery is cut. The Meklik, a rocket-launched line charge filled with explosives, can blast a swath through a minefield in seconds, but it is loud, obvious, and vulnerable to enemy fire. Tanks fitted with rollers or mine plows crawl forward, deliberately crushing or pushing mines aside, but their speed is glacial and their exposure immense. In some cases, it still falls to sappers with probes and bayonets, inching forward under fire to mark lanes with tape and stakes. Every method has trade-offs: speed versus certainty, surprise versus survivability. Commanders weigh these choices knowing that lives hang on the decision. For engineers, it means living with the knowledge that hesitation or error could doom an entire battalion waiting to pass through their work. Breaches are shielded as much by deception as by explosives. Engineers call down smoke to shroud their movements, knowing the same cloud can alert the enemy to their intent. Artillery pounds known observation posts, while drones buzz overhead to distract or jam. In those few crucial minutes, every layer of protection matters. If suppressive fires falter, if the smoke dissipates too quickly, if the enemy finds the breach point, the whole plan collapses. Reconnaissance is therefore relentless. Scouts crawl close enough to draw fire and map obstacles. Drones trace wire lines, and sappers sketch the minefield's layout by instinct and experience. A breach that looks sudden on a battle map is often the result of hours of reconnaissance and rehearsals, layered into seconds of violent execution. Yet it is the human element that defines breaching more than any device or acronym. The courage required to step into an uncleared minefield, to unspool tape under the glow of flares, to mark a safe lane while tracers snap overhead. This is a burden borne by sappers again and again. Many do not return, but those who do leave a path that others trust with their lives. Infantry rushing forward rarely stop to think of the engineers who laid down their way. But without that invisible labor, momentum halts. The engineers' work is equal parts skill, nerve, and sacrifice, and their reward is often anonymity. Breaches can decide not just battles but campaigns. An obstacle belt that holds for a day may give an enemy time to bring reserves or fortify. A breach executed swiftly can unravel defenses meant to last weeks. History is full of moments where the breach lane opened the floodgates of maneuver, allowing entire corps to surge forward. Just as often, failed breaches left armies pinned, their plans collapsing into attrition. Engineers know this weight. Their tape, charges, and rollers are not merely tools of survival. They are levers that move the course of war itself. Rivers have always been the great dividing lines of campaigns, shaping movement as surely as mountain ranges or deserts. To a commander, a wide river is both a barrier and an opportunity. If left unbridged, it shields a flank, but if crossed, it becomes a dagger thrust into the enemy's depth. Combat engineers sit at the hinge of that decision, responsible for transforming moving water into a usable roadway. Their options depend on speed, threat, and terrain. Assault boats can slip infantry across quickly, but carry little weight. Armored vehicle-launched bridges, AVLBs, can unfurl a span in minutes, but are limited by gap size and vulnerable under fire. Ribbon pontoons and ferries can move whole battalions, yet require hours of work and protection. Every choice is a gamble. Speed at the expense of capacity, stealth at the expense of momentum, or strength at the expense of surprise. In that balance, engineers determine whether an army remains fixed on its bank or flows across to change the war's geometry. The crossing is never a single action but two fights unfolding together. The first is the construction of the means to cross laying pontoons, steering ferries, securing approaches under shelling. The second is holding the far bank once the first elements arrive. Infantry surges across to seize ground that can protect engineers still building, while artillery and aircraft hammer enemy batteries that target the crossing sites. Engineers, meanwhile, work under fire to lash together floating spans, anchor them against current, and stabilize approaches chewed by explosions. Redundancy is doctrine. Multiple sites are prepared so that if one is destroyed, another remains, and alternate ferries or hidden bridging gear can be revealed at critical moments. Smoke, deception, and electronic warfare are woven into the effort to confuse enemy eyes and buy minutes. For those laboring at the waterline, every second counts, for without tempo a crossing turns into a kill zone. Defenders also employ engineers with ruthless calculation, turning rivers into fortresses. Bridges are wired with scuttling charges, piers designed with weak points to collapse under strain, and approaches mined or rigged with explosives. In this duel, timing is everything. Destroy a bridge too soon, and your own units lose a retreat. Destroy it too late, and you hand the enemy a ready-made span. Thus, engineers sit with detonators in hand, waiting for the exact moment when destruction will yield the greatest effect. Air interdiction and artillery compound the risk, cratering approaches and littering the river with debris that can foul pontoons or sink boats. Attackers counter with multiple bridging points, rapid replacements, and deception efforts that force defenders to spread their fires. Each side tries to outpace the other in an unspoken race. Who can build, destroy, or repair faster under the enemy's gaze and firepower? History offers countless vignettes where the fate of armies hinged on hours at a riverbank. Imagine a core pressed against a swollen river, its advance depending on a narrow 12-hour window before rains make crossing impossible. Engineers labor through the night, laying pontoons under blackout conditions, while smoke generators and decoy lights misdirect enemy drones. At dawn, assault boats rush across under suppressive fire, followed by a frenzy of hammering, welding, and lashing as pontoons lock into place. Enemy artillery strikes one site, killing men and sinking sections. But redundancy pays, secondary ferries are launched, and the build continues. By dusk, tanks roar across, securing a bridgehead and flipping the operational map. Success is not measured in glory but in hours bought, in a span of steel and canvas that allowed momentum to continue. For the sappers who built it, the memory is not triumph, but exhaustion. The knowledge that their sweat and risk changed the trajectory of an entire campaign. Cities are the most complex terrain an army can enter, and for combat engineers, they are both playground and nightmare. Rubble has its own geometry. It can shield soldiers from fire, but it can also choke routes and trap units in kill zones. Engineers learn to decide quickly whether to bring structures down or to shore them up. Sometimes a row of buildings is deliberately collapsed to block an enemy's approach. Other times, walls are breached with charges to create new paths for infantry. Mouseholing through apartments allows squads to move unseen, skipping streets that would otherwise be death traps. The balance is delicate. Collapse too much and movement slows to a crawl, but preserve too much, and defenders can use the cover against you. In a city, the battlefield is never flat. It is vertical and three-dimensional, and engineers are the ones who shape it into a usable map for their comrades. Route clearance in an urban fight is relentless, often more psychological than physical. Every corner, doorway, or pile of rubble could conceal an improvised explosive device. Engineers crawl forward with robots when they can, but more often it is human hands feeling, probing, and cutting. They map safe lanes meter by meter, marking them in chalk, tape, or spray so that units know where to place their boots. Beneath the streets lies another challenge. Sewers, tunnels, and basements become an unseen city where enemies hide, move, and strike. Clearing these spaces requires courage and precision, as the threat is multiplied by darkness and claustrophobia. For infantry, knowing that engineers have cleared their path provides not just physical safety, but the psychological assurance to keep moving forward into the unknown. Verticality makes the city a puzzle cube. Engineers tackle stairwells, elevator shafts, rooftops, and basements, each presenting opportunities for maneuver or traps for the careless. They breach reinforced doors into upper floors, shore up damaged staircases, and build ladders or bridges to leapfrog across rooftops. Subterranean work is equally vital, blocking tunnels, collapsing shafts, or clearing escape routes that enemies use to evade and reappear behind friendly lines. In these actions, engineers are not only fighting gravity and concrete, but also shaping the pace of the battle. Surprise is often vertical in cities, appearing suddenly from above or below to disrupt an enemy stronghold. Engineers make that possible by transforming the built environment into tactical opportunities rather than dangers. Equally important is the engineer's role in keeping the lifelines open. A cratered road or collapsed bridge can stop logistics dead, and in cities, logistics often mean survival. Engineers patch roads overnight, improvise bridges with scavenged beams, and create resupply points hidden in courtyards or garages. They also reinforce strong points, turning municipal buildings into bastions, rewiring power to keep command nodes functioning, or rerouting water supplies to sustain civilians and troops alike. These tasks are mundane compared to breaching or demolition, but they are no less decisive. A unit cut off from food, water, or ammunition in an urban fight is a unit doomed to collapse. Engineers keep arteries open so that the battle can continue. The human cost of these operations is measured not only in casualties, but in moral weight. Decisions to demolish, to block, or to reroute affect civilians who may still live in the rubble. An engineer planting charges on a structure knows that behind the walls may be families sheltering from the fight. Choices made in seconds can reverberate for decades in the lives of those caught in the crossfire. For the engineers themselves, the work is exhausting, dangerous, and often thankless, but it is also central to survival. In block-by-block advances, they are the ones who choreograph progress, enabling every move by shaping the city around the soldiers who fight within it. Without them, an army can seize blocks but not hold them, fight streets but never survive them. With them, a city becomes not just a battlefield but a system of war that can be endured and mastered. Sustaining the offensive is the quiet engine of victory. Without roads, runways, and ports that function, bold maneuvers collapse into stalled columns and idle artillery. Engineers are the craftsmen who translate consumption rates into movement, measuring how many truckloads of fuel and rounds must arrive per hour, then turning raw land into surfaces that can actually carry that load. This means more than grading dirt. It means judging soil composition, calculating bearing capacity under wet season conditions, and improvising when standard materials are unavailable. A forward airstrip might begin as a scraped field, but to support tactical aircraft, it needs compacted fill, drainage, matting, and protected fuel bladders. Each element must be timed to the tempo of operations. Engineers work with logisticians to convert abstract requirements, tons per day, into a sequence of physical tasks. Culverts replaced, potholes filled, matting unrolled, and landing lights rigged for blackout operations. Their measurements are pragmatic and unforgiving because every delay in supply ripples outward. Weapons jam, vehicles idle, and decisions that once looked bold become impossible. Turning scrub or farmland into a usable runway is an exercise in urgency and improvisation, often performed while under threat. The work begins with reconnaissance soil borings, slope checks, and selecting an approach that minimizes exposure to enemy observation. Then crews compact, grade, and apply AM2 matting or pierced steel planking, often under blackout conditions to avoid aerial detection. Fuel points must be sighted and protected, maintenance areas established, and arresting surfaces or dispersal pads created where needed. All of this requires coordination with aviation units to understand aircraft class, sortie rate, and turnaround times. A runway that supports close air support changes the tactical picture overnight, increasing options for ground commanders by shrinking the time between target acquisition and strike. But building and maintaining those fields is brutal work. Long nights of heavy lifting, welding under headlamps, and the constant threat of counter-battery fire. The payoff is operational reach aircraft that can be forward deployed to shape the battle rather than react after the fact. Ports, railheads, and over-the-shore operations are the larger-scale counterpart to runways places, where ships become pipelines of force. In littoral assaults, engineers build causeways, temporary piers, and surf mats to move vehicles from landing craft to beach without bogging in surf-zone mud. When ports are denied or destroyed, they erect improvised offload points and use RORO ramps and floating causeways to sustain the flow. Inland, rehabilitation of railheads means tamping ballast, replacing damaged ties, and sometimes improvising cranes to unload material when port cranes are gone. The logistical choreography is immense, synchronizing ship arrivals, berth capacities, and trucking assets so that queues do not form and sensitive stocks are not left in the open. Engineers also harden and conceal these nodes, burying fuel, constructing revetted storage, and dispersing supply caches so that an enemy strike cannot sever the lifeline with a single hit. The result is resilience, a theater that can take punishment and keep delivering combat power forward. Concealment and deception in logistics are not mere theater, they are active defense. Engineers build dummy depots and fake truck parks, emplace heat decoys to mimic generators, and spread false movement patterns to draw surveillance and bombardment away from real arteries. Discipline in light and noise control, especially at night, prevents enemy ISR from acquiring usable signatures, while camouflaged revetments hide the true scale of stockpiles. Conversely, hardening real nodes with blast walls, earthen revetments, and dispersed handling areas helps ensure that when strikes come, the facility survives and recovery is quick. These measures buy redundancy. An attacker who must neutralize multiple dispersed, hardened nodes requires far greater resources than one confronting a single, exposed depot. For commanders, that dispersion and deception transform vulnerability into survivability. For engineers, it is a meticulous, unglamorous craft of shaping not just the ground but an opponent's targeting calculus. Repair in contact is among the most savage of engineer duties, because it combines fatigue, skill, and immediate danger. Crews patch cratered highways with temporary plates, replace culverts with collapsible pipes, and deploy emergency decking to allow convoys to pass. All of this may occur while shells fragment nearby. Night shifts are the backbone welding splice plates, reinforcing abutments and filling bomb craters in darkness so that supplies reach forward units at first light. The tempo is unforgiving. A single ruined bridge delays maintenance cycles, creating a cascade of failures that can bleed an offensive dry. Engineers therefore operate with a contractor's attention to standards and a soldier's acceptance of risk, often improvising materials from what's available on hand. Their repairs are rarely permanent, yet they are decisive. A truck convoy that can move supplies around the clock sustains momentum and keeps commanders' options open in ways that raw courage alone cannot. Finally, the human ledger of sustaining the offensive is about trust and repetition. Commanders place the theater's lifeblood in the hands of engineer crews and expect continuous delivery. Those crews repay that trust not through spectacle but through stubborn repetition. Inspecting every culvert, rotating maintenance shifts, and pre-positioning bridging kits so that when a gap opens, they can respond in hours, not days. That reliability allows bold maneuvers. If a commander knows a supply corridor will hold, they can gamble on deep thrusts and envelopment. If they doubt it, caution rules and opportunities vanish. Engineers thus underwrite risk at scale. Their quiet labor becomes the margin between audacity and paralysis. In the end, sustaining the offensive is not heroic fireworks, but a long ledger of small recoveries and endless maintenance work that earns victories by keeping the arteries of war flowing. One repaired culvert, one matting roll, and one sleepless night at a time. The human dimension of the engineer's war is the place where tools meet flesh and courage becomes a daily habit. Sappers are craftsmen and improvisers first, but they are also soldiers who shoulder disproportionate risk. Their tasks, breaching, bridging, clearing IEDs, place them at the point of greatest friction. In the field, this translates to long, punishing cycles of labor and danger. Nights spent welding under blackout conditions, dawns when explosives are laid with hands that have not warmed since the last shift, and days when every decision must be made with the knowledge that a single error can cost lives. The work breeds a particular kind of discipline, fastidious, procedural, and relentlessly repetitive, because precision under pressure is the only currency that buys survivable outcomes. That discipline is learned in training and reinforced in the crucible of the line, where muscle memory and checklist replace hesitation and doubt. The sapper's paradox is that visibility and recognition rarely follow the scale of sacrifice. Engineers are celebrated in small units and quietly treasured by commanders, but they remain largely invisible in broader narratives of combat. The bridge that holds the column, the lane that lets boots pass, the fuel point that keeps the gun firing, these are rarely center stage in dispatches, yet they determine whether an operation collapses into attrition or blooms into maneuver. For the individual sapper, the psychological reward is often intrinsic, the satisfaction of a job done precisely, the shared jokes over a headlamp, the quiet pride when a convoy passes safely because of work done through the night. But there is also a cost. Repeated exposure to danger leaves scars, sleep disorders, simmering hypervigilance, and the knowledge that one's value is often measured in things unseen by the public eye. Leadership matters more for engineers than in many other military trades because commanders must literally bet their maneuvers on the crew's output. Orders to breach or to build under fire are moral and tactical judgments. Commanders who ask for a night build are choosing to expose their sappers to extraordinary hazard in the hope of buying hours for maneuver. That gamble requires mutual trust. Good leaders know the limits of their crews, provide realistic timelines, and stand visibly with them when the risk is greatest. Conversely, poor planning ambitious timelines without adequate protection or unrealistic expectations of output translates directly into casualties and broken morale. In the human ledger of combat, leadership choices about engineers accumulate quickly. For every build deferred or rushed echoes down supply lines and into the lives of soldiers who depend on the work. Camaraderie and unit culture shape how sappers endure the grind. Engineer units commonly cultivate a robust esprit de corps, dry humor under fire, rituals around equipment checks, and an ethic that values ingenuity above showmanship. That culture produces improvisation under scarcity, jury-rigging a bridging clip with scrap metal, fashioning a makeshift smoke generator from scavenged parts, or teaching a fresh crew to splice a detonation cord correctly while artillery thumps in the distance. These are learned arts, transmitted in the barracks and refined in the field. The result is a workforce that prizes competence and mutual care. When a team trusts that each member will check the knot, sweep the lane, and mark the route properly, the collective risk is reduced. That trust is fragile but powerful, and it is often the real margin between success and catastrophic failure. The physical toll is severe and cumulative. Engineer tasks are intensely physical: shoveling, welding, lifting heavy bridging sections, and bending into awkward positions to emplace charges or probe suspicious ground. And they are often done in extreme environments. Wet seasons turn everything to muck. Desert heat saps judgment and causes equipment to fail. Urban rubble abrades muscles and exposes crews to collapsing structures. Sleep deprivation compounds the danger. A welder's hand that trembles at 0300 can produce a faulty splice. A sapper who has been awake for 30 hours is statistically more likely to make an error with lethal consequence. Medical care in the field can treat wounds, but it cannot erase the slow attrition of bodies worn down by relentless tasks. The human ledger includes both immediate casualties and the long-term wear that reduces a unit's effectiveness over months of operations. Moral stress and ethical complexity are inseparable from the engineer's mission, especially in populated areas. Decisions to destroy infrastructure, to prioritize military lines of communication over civilian needs, or to employ demolitions that risk creating long-term hazards, impose heavy judgments on those who carry them out. Engineers may be ordered to demolish a bridge knowing that villagers rely on it for food. They may be asked to render a water treatment plant unusable to deny enemy access but thereby imperil civilians. These are not theoretical dilemmas. They are choices made in fog and under time pressure, and they bear on the conscience of the individuals who execute them. Units that confront these moral burdens openly, through pre-deployment training, legal counsel, and leadership discussion, tend to exhibit greater resilience and fewer chronic stress injuries. The moral dimension, like the physical, is part of the craft and must be treated with equal seriousness. Finally, the future human landscape of engineering warfare will be shaped by changing technology, but not without transition pains. Robotics, autonomous breaching systems, and remotely operated bridging modules promise to reduce exposure, but they also demand new skills, new maintenance chains, and different cognitive loads. Sappers will need to be technicians and tacticians, able to diagnose a drone's failure, jury-rig a replacement actuator, and then switch back to the brutal physicality of filling a culvert under fire. The cultural core, the discipline, the trust, the willingness to accept risk for the sake of others will remain essential. Technology may reduce some hazards, but it will also create novel stresses and expectations. The human dimension endures. At the end of the day, a machine is a tool, and the decision to press it into a dangerous moment still falls to people whose courage and judgment will always decide whether the ground favors friend or foe. Combat engineers are often called the arsenal behind the lines, but the truth is that they are not behind anything. They are embedded in the marrow of every campaign. They shape the space where battles unfold, crafting bridges and roads that sustain momentum, carving breaches that allow entire divisions to surge forward, and collapsing obstacles to strangle an enemy's timetable. Their fingerprints are invisible to history's headlines, yet they are etched into the tempo of war itself. A battle remembered for an armored breakthrough is, in fact, Also the story of engineers who laid the bridge, cleared the minefield, or kept the supply road alive through sleepless nights. To grasp their legacy is to accept that victory in war depends not only on courage at the point of attack, but also on craftsmanship at the margins of terrain and time. This legacy stretches across eras. At Gallipoli, engineers dug trenches in impossible terrain, though poor planning doomed the effort. At Normandy, combat engineers cleared beach obstacles under murderous fire, their lanes becoming lifelines for the infantry. In Korea, Incheon's landing succeeded not just because of bold strategy, but because engineers prepared seawalls and causeways to allow tanks to roll inland. Modern conflicts in Iraq and Afghanistan saw sappers probing for IEDs, breaching city blocks, and keeping fragile supply corridors open in hostile deserts and mountains. Each story is different, yet the pattern is the same. Where engineers delivered, maneuver thrived. Where they failed, momentum withered. Their history is not one of grand speeches, but of bridges held, lanes marked, and roads patched in the darkest hours. The future promises new tools, autonomous breaching machines, 3D printed fortifications, drones that survey obstacles, and energy-based demolition methods. But the essence will remain unchanged. War still takes place in physical space, and someone must still shape that space under conditions of danger and scarcity. Even with machines, the moral and tactical judgments will fall to humans. When to destroy, when to preserve, when to risk lives for minutes gained. The castle insignia may adorn soldiers who handle robotic systems instead of shovels, but their role will still be to turn terrain into a weapon for their side. Their craft will still be measured not only in steel and earth, but in trust, time, and sacrifice. In conclusion, the story of combat engineers is the story of war itself told from the perspective of those who build the stage on which it plays out. They are not simply adjuncts to infantry or armor. They are war makers in their own right, creating freedom of maneuver and denying it to the enemy. Their work is quiet, often unheralded, yet decisive. To ignore them is to misunderstand how campaigns succeed or fail. Their legacy is written not in statues or medals, but in the bridges that carried armies forward, the lanes that let soldiers survive, and the roads that kept momentum alive. And so long as war endures, the arsenal behind the lines will remain one of its most decisive and enduring weapons.
Thank you for joining us on the TrackPad's Military History Podcast. If you enjoyed this deep dive into the battlefield, be sure to explore more articles, episodes, and series at trackpads.com.